Assalamu alaikum my dear students, hope you are well by the grace of Almighty Allah. Welcome to NIBS Homeschool. This is Mohammad Emdadul, Assistant Teacher of Mathematics, National Ideal English Version School, Dashing. Dear students, today I am going to conduct a higher mathematics class of class 9. Our today's topic is chapter 11, basic discussion, and exercise 11.1, activity 1, question 5, and question 2, question 5. These three questions I will solve after the basic discussion. Okay, dear student, and after completing my class, I will give you some work, that is your homework number 20 and lecture number 26 today. Your homework is exercise 11.1, question 3, 4 and 6. These three questions you have to do as your homework. Okay, dear students, I hope when you will complete today's class, you will be able to complete your homework. So do the homework, you have to understand everything in our today's class. Okay, dear students, let us start our today's class. Today we will learn the topic coordinate geometry, rectangular Cartesian coordinate system, determining distance between 2 points, solving problems related to distance. These topics we will discuss in today's class. It means this is our learning objectives. These are our learning objectives today. Okay, dear students, at first see what is coordinate geometry. The portion of geometry where the algebraic expressions of points, straight lines and curved lines are studied is known as the coordinate geometry. Here this is the definition of coordinate geometry. The portion of geometry where the algebraic expressions of points, straight lines and curved lines are studied is known as coordinate geometry. This is the definition of coordinate geometry. This portion of geometry is also known as analytic geometry. This portion of geometry is known as analytic geometry, with the plotting of points on the plan, the straight lines or the curved lines or the figures of the geometric regions made by them, such as the triangles, the quadrilaterals, the circles, etc. are expressed. It means if we put the points on a plan and then joining the points, so we may get different figures on the same plan. Okay, now the system of plotting of points on the plane was initiated by a French mathematician named René Descartes. So we need to know the name of the mathematician. He is French mathematician René Descartes, known as Descartes. The coordinate system of geometry initiated by Descartes is called Cartesian coordinate system after his name. So here the Cartesian coordinate system definition. The coordinate system of geometry initiated by Descartes is called the Cartesian coordinate system after his name. So we have to write the definition after this coordinate system. Okay, now the coordinate geometry and the analytical geometry are mainly based on the Cartesian coordinate system. Our coordinate geometry and analytical geometry are mainly discussed based on the Cartesian coordinate system. So Descartes is called the initiator of analytical geometry. For this reason, Descartes is called the initiator of analytical geometry. Descartes is called the initiator of analytical geometry. Now, next topic, coordinated geometry is done now. Now we will go to the next topic. Next topic is rectangular Cartesian coordinate system. So I will discuss rectangular Cartesian coordinate system here at first. We have been acquainted with the concept of plan in previous class. In different classes, in class 6, in class 7, we have learned about the concept of plan, the surface of a table, the floor of a room, the surface of a book, even the paper on which we write down. Each of them is a plane. It means surface of a table. Suppose here is the board. This is a plane. These are the examples of plane. The surface of a football or the surface of a bottle are curved planes. As the surfaces are curved of bottle and football, these are known as curved planes. In this part, the tricks of determining the proper position of any point lying on the plane will be discussed. In this part, in rectangular coordinate system, Cartesian coordinate system, we will learn the trick of determining the proper position of a point. So in Cartesian coordinate system, basically we will learn how can we determine the position of a point, particular position or exact position of a point. It is necessary to know the distance of the definite point from the straight line bisectors constructed on the plane. It is said as a reason that only a point can lie at any definite distance from two straight line bisectors. Okay, dear students, now I will explain this here in this class. Okay, now see. If two such straight lines x o x dash, in the figure if you see x o x prime or x dash and y o y prime are drawn that intersect each other at o at right angle on any plane. This is a plane. Okay, now x o x prime is called the x axis. X o x prime is called the x axis and y o y prime is called y axis, and it means this horizontal line is known as x axis and this vertical line is known as y axis, and these two lines intersect each other at right angle. Now let P be a point on the plane of the two axes. From point P on x o x dash, that is the x axis, and on y o y dash, that is the y axis, the perpendiculars are respectively PM and PN. It means from point P, PM is a perpendicular on OX, it means x axis, and PN is a perpendicular from to y axis, means y o y dash. Okay, the distance of a point P from the y axis, distance of point P from the y axis is NP equal to OM is equal to X, is called abscissa. It means the distance of the point from y axis or the vertical axis is known as abscissa of P or X coordinate. So this is called abscissa of P or X coordinate. Abscissa of P or X coordinate. Then again the distance of point P from x axis is equal to, two equal given here, only one equal will be here, is equal to PM or MP equal to ON equal to Y, and this is called ordinate. This is called the ordinate of P or y coordinate. So distance of point P from the y axis is abscissa or x coordinate, and distance of P from x axis is known as ordinate of P or y coordinate. The abscissa and the ordinate are jointly called the coordinate. So if we jointly say the abscissa and the ordinate of a point, that is known as coordinate of that point. So in the figure, the coordinate of P means the perpendicular distance of P from the y axis and the x axis, and by denoting them as x and y, the coordinate of P expressed by the symbol Pxy. So this is the point Pxy on the plane xy plane, Okay, now the coordinate index xy means the ordered pair whose first element indicates the abscissa and the second element indicates the ordinate. So first element means x indicate the abscissa and y indicate the ordinate. Abscissa means the distance of a point from the y-axis and ordinate means the distance of a point from the x-axis. So if x is not equal to y by xy and yx, two different points are meant. It means if x and y are not equal, then xy and yx are two different points on the plane. Therefore, the coordinate of any point depending on two axes intersecting each other at the right angle is called the rectangular Cartesian coordinates. So we can say the definition of coordinate here, rectangular Cartesian coordinates, the coordinate of any point, depending on two axes intersecting each other at the right angle is called the rectangular Cartesian coordinates. So we can say if any point, if we consider P is any point, so coordinate of P is xy. So this system is known as rectangular Cartesian coordinate system. If the point P is placed at the right side of the y-axis, if it is on the right side of the y-axis, then the abscissa will be positive. So it means in this side this is positive, the abscissa will be positive. If it is placed at the left side, then it will be negative. Okay, then the abscissa will be negative. Again, if the point is placed above the x-axis, if the point is placed above the x-axis means in this way, then it will be positive, ordinate will be positive, and if it is placed below the ordinate, below the x-axis, then the ordinate will be negative. On the x-axis the ordinate will be 0, on the y-axis the abscissa will be 0. It means that suppose if I draw here, this is x-axis and y-axis. Now if we take any point on the right of y-axis, suppose here is P, this P, abscissa is positive here. If we put the point P here, then consider this point, and this is on the left side of the y-axis, it means abscissa will be negative. If we put the point above x-axis, suppose this point is above x-axis, then ordinate will be positive. If we put below x-axis, the ordinate will be negative. It means we can say from 0 to right the value of x is positive, value of x coordinate is positive, and if we move to left the value of x coordinate will be negative, and if we move to upper the value of y means y coordinate will be positive, this will be plus, and if we move to the below, then value of y will be negative. This means ordinate will be negative. Okay, dear students, I hope you have understood this, and for this now we can say if we consider any point on the x-axis, its ordinate will be 0. If any point lie on the y-axis, its abscissa will be 0, and then so the positive abscissa and the ordinate of any point will be along on OX and OY respectively or parallel to them, it means that if both are positive, that will stand on this part. If first one is negative, similarly the negative abscissa or the ordinate will be along on this part if both are negative. If x is positive and y is negative, then that point will lie on this part, and if x is positive, y is negative, then lie on this part, then will lie on this part. Okay, now each of them is called coordinate. Now by the two axes of the Cartesian coordinates, the planes divide into four, means x o y, y o or x y o x dash o y dash o x, these four parts. It means the plane can be divided into four parts. These four parts are indicated by this symbol. Each of them is called a quadrant. So this, we have to consider the quadrants anti-clockwise. Anti-clockwise, it means it will move in this way, this direction, in this direction. This direction means anti-clockwise. So this will be known as first quadrant, and this part is known as second quadrant, this part is known as third quadrant, and this is the fourth quadrant. Okay, dear students, now we have discussed which point will lie on which quadrant. If both the coordinates of x and y is positive, the point will lie on the first quadrant. If the abscissa is positive and ordinate is negative, that will lie on the second quadrant. If both are negative, that will lie on the third quadrant. And if abscissa is positive and ordinate is negative, that will lie on the fourth quadrant. So using this information, we can put any point, or we can plot any point on the graph, or on the plan. We can determine the position of any point. Okay, dear students, now I have completed rectangular Cartesian coordinate system. Now I will discuss about distance between 2 points. I will discuss about distance between 2 points. How can we determine the distance between 2 points? Dear students, distance between 2 points is discussed here in detail. Just I will show you from the figure. Now see here, suppose P is a point here and Q is a point here, and coordinates of P is x1 and y1, and Q is x2 and y2, x2 and y2. So now we need to determine the distance of PQ. How can we determine the distance of PQ? For this, we can draw a perpendicular PM and another perpendicular QN. Now draw perpendicular PR on QN. From this figure, we can determine the distance PQ easily. At first, we can say from this figure, here point P means PM here, PM means the perpendicular distance of point P from x-axis, that is y1. And if we consider if this is O, origin, OM, then this will be OM equal to x1. And if we consider ON, this ON will be x2 and QN will be y2. Now from this we can say, we can determine the value of PR at first. Now determine the value of PR. How can we determine the value of PR? From the figure, we can determine the value of PR as we can determine the value of Mn. PR equal to Mn. Here from the figure we can say Mn means On minus Om. On minus Om. So put the value of On is x2 and Om is x1. Now determine QR. Here QR means we can write QR means Qn minus Rn. Qn minus Rn. Here Rn means Pm. Rn equal to Pm. So we can write Qn minus Pm. Now Qn means y2 and Rn Pm means y1. So y2 minus y1. Now we know the distance. Now we know the length of PR, that is x2 minus x1, and length of QR, that is y2 minus y1. Dear students, now we can apply the theorem of Pythagoras, as this is a right angle triangle. PQR is a right angle triangle. So we can say PQ is the hypotenuse. So we can apply the formula of Pythagoras. We can write PQ square equal to PR square plus QR square. Now put the value of PR. PR means we can write here PR means x2 minus, I have determined PR, x2 minus x1 whole square, plus QR means y2 minus y1, we have determined whole square. Therefore we need the distance PQ. PQ means plus minus, we can apply as we are taking square root in right side. As here is square, we are removing square, we can take square root. X2 minus x1 plus y2 minus y1 whole square. Okay dear students, now if you notice here PQ means a distance never be negative, so we can say the distance of P from Q, or distance of Q from P is PQ. That will be, we need to consider that must be positive. Therefore the distance PQ must be positive, x2 minus x1 whole square plus y2 minus y1 whole square. So this is the required distance between 2 points P and Q. We can determine the distance from Q to P also. The distance will be same. In that case we will get the distance of QP. The distance in the same process we can determine QP, distance from Q to P, that will be x1 minus x2 whole square plus y1 minus y2 whole square, square root x1 minus x2 whole square plus plus y1 minus y2 whole square. As here is whole square, so x1 minus x2 and x2 minus x1 both will be same. y1 minus y2 and y2 minus y1 both will be same, as whole square is given. So from this we can say PQ equal to QP. It means for any 2 points the distance will be always same, and we will get, in case of distance, just we will get the absolute value. Dear students, now if we consider any point is origin, suppose P is a point here, the coordinate of P is xy, Now determine the point from origin. Origins means O. Here both the value of x and y coordinate is 0 here at the origin. So the distance will be now OP, and this will be equal to square root. We have to put 0. It means x minus 0 whole square plus y minus 0 whole square. That will be x square plus y square. It means distance of any point xy from the origin will be equal to square root x square plus y square, square root x square plus y square, if we determine the distance from the origin. In that case we will get this formula, and if x1 y1 and x2 y2 be 2 points, then the distance will be square root x1 square root x2 minus x1 whole square plus y2 minus y1 whole square. Okay, dear students, so I have shown you how can you determine the distance between 2 points. Now I will solve problems from exercise 1.1. 11.1, exercise 11.1. At first I will solve question 1.5. It means first question, our first question is this one, 1.5, and I have written the question here, activity 1, question 5. Here we need to determine the distance, find the distance between the given points minus 3/2 minus 1 and minus half 2. We have to determine the distance between these 2 points. Okay, so we can determine distance. We have discussed here determining distance between 2 points. Now I'm going to solve problems related to distance. So at first I'll solve this one. Find the distance between the given points minus 3/2 minus 1. This is a point and another point is half 2. Okay, this is a point. So we can write here exercise 11.1, exercise 11.1, activity 1, question 5. We can write here given 2 points. 2 points are, here the 2 points are minus 3/2 minus 1 and another one is half 2. Now we need to put this point at first on the graph or on the plane. So we can draw the figure here. We can draw the figure. Now 3/2 means 1.5. If we consider this is negative, so here will be 1.5. Suppose here is 1.5 and 1. Here is 1.5 and 1. And another point is half and 2. So here will be half and 2 here. Suppose here. So we need to determine the distance between 2 points minus 3/2 minus 1 and another one is half 2. So we need to determine the distance, means this we need to determine. Now to determine the distance we can write here, we know the distance between 2 points x1 y1 and x2 y2 is equal to square root x2 minus x1 whole square plus y2 minus y1 whole square. Therefore we can determine the distance between these 2 points. So the distance between two points minus 3/2 minus 1 and half 2 is equal to, we can take the square root here, minus 3/2. At first we can take here x2 means half, minus 3/2 is x1. We need to give square plus y2 minus y1. y2 means 2 minus y1 means minus 1. So we have to give the square here. Now if we calculate, what will we get? We'll get here half plus 3/2 whole square plus 2 plus 1 whole square. So we can write here, if we add this 2, we'll get here 4/2 whole square plus 3 whole square. What does it mean? 4/2 means 2 square plus 9. So we can write here 2 square means 4 plus 9, square root 4 plus 9, it means square root 13, square root 13. Therefore the required distance between the given points is square root 13. So we can write therefore the required distance is square root 13, square root 13. Okay dear students, so I have solved the first question. Now I will solve question 2. See the question 2. What is question 2 here? See the question at first. The three vertices of a triangle are A 2 minus 4, B minus 4 4 and C 3 3 respectively. Draw the triangle and show that it is an isosceles triangle. Show that it is an isosceles triangle. So at first we have to draw the triangle, plotting the points on the graph. You can use the graph paper. I will not use the graph paper, just I will draw the figure without using graph paper. Just I will show the plane here. Now see, this is x-axis, x o x dash, y o y dash. Now the points are we need to see here. First point is A 2 minus 4, 2 minus 4. So 2 minus 4 means this is plus plus, this is minus plus, this is minus plus, this is minus minus, and this is plus minus. So we need to go to plus minus at first here. So we need to move 1 2 and below 4, 1 2 3 4. So suppose this is minus 2, 2 minus 4, 2 minus 4. So this point is A, this point is A. Now we can plot another point here, minus 4 4. So x is negative here, so we can write here 1 2 3 4 suppose, and above 4 1 2 3 4. So consider this is minus 4 means B. This is point B. Now another point we need to plot C3 3. Here is 3, here is 3 suppose. So this is point C, this is point C. Now join these 3 points, you will get a triangle. You will get a triangle. This triangle is known as isosceles triangle. This triangle will be an isosceles triangle. We need to prove. To prove this, we need to determine the distance of the 3 points from. It means we need to determine the distance of AB, BC, and AC. Now we need to check. So we can write here question 3. We need to write here question 2. Given A equal to, it means point A is 2 minus 4, B is minus 4 4, and C is 3 3. B 3 points B3 points of a triangle ABC, of a triangle ABC. Now we can determine the length of the triangles or sides of the length of the triangles. At first we can determine AB equal to, now we need to use the formula that is determining distance. So AB means here x2 minus x1 minus 4 minus 2 whole square plus y2 minus y1. So we can write here 4 minus 4. So we can apply here directly, minus will be plus, or it will be little bit hard for you to understand. We can write in detail, not in short. We can write here minus 4 plus sorry, not plus here, minus 2 whole square plus, as here is 4, then minus 4, then this will be square. So we can determine here square root minus 6, this will be minus 6 whole square plus this is 4 plus 4 whole square. We can determine here, minus 6 whole square means 36 plus 448 square, that is equal to 36 plus 8 8 are 64, means square root 100 means 10. Square root 100 means 10. We have determined the distance of A and B. Now we need to determine the distance of BC. We can determine BC. How can we determine BC? So now BC, so 3 minus 4 plus 3 minus 4, that will be equal to now 3 plus 4 whole square plus 1 plus minus 1 whole square, that is equal to, we can write here 7 square plus 1 square, means 7 square means 49 plus 1 square means 1, that is square root 50. Square root 50 means we can write this as 5 root 2, 5 square root 2. Okay. As we can express 50 as 25 into 2, so we can take the square root of 25 is 5. Now we need to determine AC. So determine AC. What is AC? AC. So now 3 minus 2 whole square, x2 minus x1 plus y2 minus y1, y2 minus y1, y2 3 minus 4 whole square plus, not plus, equal, then 3 minus 2 is 1 square plus this is 3 minus 4 means plus 4, 3 plus 4 whole square, that is equal to 1 square means 1 and 3 plus 4 means 7 square, that is 1 plus 49, that is equal to 50. Now 50 means square root 50 means 5 root 2, 5 square root 2. Now see, if you see the length of the side BC and AC, these two sides, length of these two sides are equal of the triangle ABC. As the length of the two sides of a triangle are equal, then the triangle must be an isosceles triangle according to the definition of isosceles triangle. So we can say, observe that BC is equal to AC. BC is equal to AC. So therefore AC in the triangle ABC, therefore a triangle ABC is an isosceles triangle, is an isosceles triangle. Is an isosceles triangle. Okay, dear students, so I have solved question 2. Now I will solve question 5. Question 5. Okay, dear students, now go to question 5. What is question 5? Question 5 is, if 2 points minus 5, 5 and 5k are equidistant from the origin, find the value of k. We need to determine the value of k if these 2 points are equidistant from the origin. So try to understand the figure at first. Suppose here is a point Suppose this is origin. Here is a point minus 5, 5. So minus 5, 5 means this point. Suppose this is minus 5, 5. So this distance is equal to, if any point 5k, if these two distances are same, it may be here also, in any place, in this quadrant or this quadrant. This may lie as 5 is positive here. Okay, it may lie here or here. After determining the value of k, exactly we can say the point will lie on first quadrant or in fourth quadrant. We need to determine the value of k, but we need to remember that the distance of the point 5 minus 5, 5 and 5k is same from origin, means 0, 0. Origin means 0, 0. We need to determine the value of k using this information. Okay, dear students, now see how can we solve. Question 5. Given 2 points are minus 5, 5 and 5k. We need to determine the value of k. Another condition is given, that is, these 2 points are equidistant from the origin. Let the origin O is 0, 0. Origin O 0, 0. Origin O is 0, 0. Generally, origin can be denoted by O and its coordinates are 0, 0. It means abscissa and ordinate both are 0 at the origin. So we can determine the distance of point minus 5, 5 from origin. So determine the distance between 2 points 0, 0 and minus 5, or we can write minus 5, 5 and 0, 0. So we will get the distance here. What will be the distance? We can determine here. That will be 0 minus 5 whole square plus 0 minus 5 whole square. Now see what will be if we calculate here. If we calculate here, we will get here, this is plus 5 whole square plus 5 whole square minus 5 whole square minus 5 whole square. This will be equal to 25 plus 25. That will be equal to 50. 50 means 5 square root 2. 5 square root 2. Again, distance, we can use the distance between 2 points 5k and 0, 0 equal to. So we can determine the distance here, 0 minus 5 or 0 minus 5 whole square plus 0 minus k whole square. This will be equal to 5 square minus 5 square plus minus k square. That is equal to square root 25 plus k square. Okay. Now these two distances are same. No need to determine this one. You can stay here. So these two distances will be same, as the points are equidistant from the origin, as the points are equidistant from the origin, so their distance will be equal. It means that square root 25 plus k square is equal to square root 15. If we take square on both sides, if we squaring both sides, we will get 25 plus k square. Squaring both sides, we get 25 plus k square equal to 50. It means that here k square is equal to 50 minus 25, or k square is equal to 25. Therefore k equal to plus minus 5, taking square on both sides. So value of k is plus minus 5. It means it may be plus 5 or minus 5, plus 5 or minus 5. As we have taken square root, we have to take plus minus sign, as we removed square from the left side. Okay, so the required value of k is, so the required value of k is plus minus 5. Okay, dear students, so I hope you have understood the solution of question 5. Dear students, 3 questions are given depending on today's lecture as your homework. Exercise 11.1, question 3, 4 and 6. You can solve these 3 questions properly and practice this at home. Submit your homework timely. Keep practicing at home. Avoid by your parents. Stay home. Stay safe. See you again. Till then, Assalamu alaikum.